tricky in algebra? Not tricky in the sense of hard. I mean tricky for teachers because we're not really sure how much they get tested. So what your individual teachers did might vary a little bit. So generally speaking, piecewise function is a function that is split up into 2 pieces or 3 pieces or 4 pieces, whatever. And each piece is only used along a certain interval. So on this first one, between -1 and 1, we use the first piece. Between, or greater than 1, we use the second piece. And right at 1, we use the middle piece. Okay? So the easier part is evaluating. If they ask you to find f of 0, you're plugging in a 0 to which piece. You just have to look which one of those intervals contains 0, the first, the second, or the third. The first. So then that's the one that you plug 0 into. So -0 plus 1 is just 1. F of 1, which piece would I use for that? The first, second, or third, Carolina? No, this one, yeah, right, this one says you only use it if it's less than 1. Right, the second one, right? And if this is another tricky question, if I plug 1 into this, what do you get? Just the 2 that's there, because there's no variable there. And for f of 2, 2 being greater than 1, I use the third piece. 2 squared is 4. The domain. Now, I don't know if you've noticed this, but this one actually is not going to negative infinity. If they asked you to find f of -5, none of those intervals contains -5. Do you agree with that? This one's between -1 and 1, including -1, but not 1, because as soon as we get to 1, we're using the second, and as soon as we get past 1, we're using the third. So the overall domain, what's the lowest x value I can plug in? -1, and then I can plug in anything up to infinity. Okay, now here's the graphing piece, and I don't know how much you graphed last year, probably not much, to be honest. The first thing I'm going to do with the graphing situation is come up with my different intervals. So actually first here I'm going to throw an x and y axis on here. And I'm going to use dotted lines to kind of show me, like, this little section is going to be one piece, this little section is going to be another, and then so on and so forth. So from -1, which is here, up until +1, so in between these 2 dotted lines, that's going to be my first piece. And we can do that first. And you can graph that just by graphing the line, -x plus 1. So based on y equals mx plus b, Mike, what's the y-intercept? Y equals mx plus b. And this equation is y equals -x plus 1. So what's my y-intercept here? 1. And what's my slope? Right, -1 over 1. Right, so down 1 over 1, down 1 over 1, down 1 over 1. And that line in its entirety, and you don't need to graph this because I'm about to erase some of it. That line in its entirety, independent of the piecewise function, would look like that. But we only want to see that from -1 to 1. So I'm going to erase anything that's outside of those lines. And I need to use specific endpoints. Whether they're open or closed is what I'm really trying to show here. So at -1, 2 is technically the point. Is that an open circle or a closed circle? Closed, because we want to include the x of -1. And then at 1, 0, is that an open circle or a closed circle? open. Because in that first equation, I'm not including 1. So that's the first piece. The second piece really isn't an interval at all. It's specifically right at 1, the y coordinate needs to be 2. That's just a single point, 1, 2. So that's going to be a closed point right there. And then the last function is x squared. Now, this is, and I'm going to do it up on the board so I don't screw up the picture. But if I'm just graphing x squared on its own, looks like this. Right? That's just a parent graph. So if I just want to see that where x is greater than 1, I'm getting rid of anything that's less than 1. And then right at 1, what am I doing? That's an endpoint when it's no clear close. Open. So it's going to be kind of a parabola from that point forward. Does that make sense? So starting at 1, 1 with an open circle. And then you could look at more points if you wanted. So 1, 1, and then it actually gets pretty steep pretty quickly. So here's what has to hold true for piecewise functions, because they are still functions. They have to pass the vertical line test. So anywhere I put a vertical line, it can only hit this thing once. Now the one area of interest is right here at x equals 1. That vertical line sort of hits the graph 3 times, it appears, but not really, because those other 2 locations are open circles. Does that make sense? Okay. So now that we see the graph, and if we're asked to evaluate the range, what's the lowest value this graph ever gets? Range, so we're talking y coordinate lowest. 0, does it actually reach 0? No, because it's an open circle. And the highest? Infinity. Does it skip anything in between? Right. It hits everything from 0 to 2, and then it hits everything from 2 and beyond as well. Sometimes they can skip little sections in the middle, and you have to watch out for that, but this one does not. Any questions? Yeah. Like if it did something like this to 2, and then skipped and went up, you'd have to go 0 to 2, and then let's say it picked back up at 4, and then you'd have to go 4 to infinity, something like that. You would have to definitely show that, because 3 is not in there. That got jumped over. Yep. Are you talking here? Yeah, horizontal line test talks about whether or not this has an inverse, and to be truthful, we don't talk about inverses with piecewise ever. So yeah, you don't care. Y coordinates can repeat, x coordinates can't. So back to all that algebra 1 stuff. Okay, number 2. We'll do 2A, obviously, first. The domain. So x is less than 1, x equals 1, and x is greater than 1. So what is our domain? All real numbers, right? Nothing gets skipped. Negative infinity to infinity, so this will exist everywhere. Now, intercepts is an interesting thing. If this just said find the x-intercepts, find the y-intercepts, and it didn't tell you to graph, you don't want to have to graph an entire function to answer that question, right? Algebraically, how do you find the y-intercept, for example? What do you set? Who said that? I was going to say it better be one of my kids, because we were all over that on our flashcards last year. No matter what function, if you want the y-intercept, you set the x-coordinate equal to 0. So if I'm doing that for this guy, and I'm going to plug in an x of 0, which piece does that go into? Sarah, first, second, or third? If I'm plugging in an x of 0, does it fit in this interval, this one, or this one? First, right, because 0 is less than 1. So I would just plug it in there, and I would get that the y-intercept is 0. So with the y-intercept, you know what x you're plugging in, so you just pick the appropriate piece. And you should only have one y-intercept, correct? If you ever had two y-intercepts, here and here, you would not be a function, right? You'd fail the vertical line test. So you can only have one y-intercept, so that's that. X-intercepts, you can have multiples. You guys know that. You've graphed a lot of things over the past year that have multiple x-intercepts. And to find those x-intercepts, you set y equal to 0. Now this is tricky because it doesn't tell you what interval to use for your y-coordinate being 0. Your intervals are set according to what x is. So if you're setting y equal to 0, this, by the way, is y, right? Y equals, f of x equals. So it's 0 equals, and we have 3 different pieces to solve for. You have to do this, however many pieces there are, you have to do this that many times. Do you follow? So if I first do the first piece, if 0 were to equal negative 2x, what would x be? 0. Here's the question. Because this answer came from the first piece equation, is that an okay answer for that interval? Yes, right? That x is less than 1, so that is definitely an x-intercept that's going to show up. In your second piece, when you set 0 equal to negative 1, there's no solution to that anyway, right? There's no x to solve for, so there's no solution. And in our third piece, if 0 equals x squared plus 2, and we solve for that by subtracting 2 to from both sides, square rooting both sides, what do you get? Right, an imaginary number, and there's no such thing as an imaginary x-intercept. So that actually doesn't give you anything. Do you follow? Just watch me. You don't have to do this necessarily, but just because I want you to see another one. This whole thing, all your intervals are switching gears at 1. So the first graph, negative 2x, is linear. It's got a y-intercept of 0, and it goes down 2 over 1, down 2 over 1, down 2 over 1. So it would look like this. Except for, like, in its entirety, it would look like this. Except for this is chopping it off and saying, I only want to see this when we're less than 1. So I have to get rid of this side, and I have to give it an open circle right there. So I'm only seeing that when x is less than 1. So do you see the x-intercept now? That's why we kept it. Sometimes we actually erased the side that had the x-intercept, and that one would have been rejected because we would have gotten an answer that was not in the interval. At 1, we're at negative 1, so 1, negative 1 is a solid point. And then beyond 1, this is just a parabola shifted up 2 units, right? Parent graph. So if I shifted up 2 units, it would look like this in its entirety, though. But we only want to see it when it's greater than 1, so that's from here and beyond. So we have to get rid of the piece that's less than 1. And again, an open circle. Good? Okay, this one, x-intercept. Oh no, I'll do y first because that's easier. Y-intercept, set x equal to 0. Which equation, JR, am I plugging into if x is equal to 0? First or second? Good. So 0 squared plus 1 tells me y-intercept of 1. X-intercept, we're setting y equal to 0, so we have two things to do here. We have to do 0 equals x plus 7, and we have to do 0 equals x squared plus 1. Oh, this is a bummer. I'm not going to get any of the fun ones. So if I subtract 7 on this one, I get x equals negative 7. That came from the first piece. So look at your first interval. Do I keep that or not? Is that answer less than or equal to negative 3? Yes. So in other words, when I graph it, I'm not erasing that portion of it. And so therefore I still have the x-intercept. Over here, we're going to get nothing again. Okay. I want to find an x-intercept that I'm going to have to get rid of. So just on the back quickly, x-intercepts. So I have 3 pieces. I have to do this 3 times. The first piece, when I add 1 to both sides and divide by 2. Okay, here we go. Is that in that interval? This line on its own would have an x-intercept of 1/2. But 1/2 is not less than 0. So I would reject that. That's not actually going to be an x-intercept. Because if I graph 2x minus 1, it would look like that. So that line in its entirety does have an x-intercept of 1/2. That is true for the line in its entirety. But we only want to see this line when it's less than 0. So we're not going to see that x-intercept. It was actually on a part of the line that we had to erase. Does that make sense? Okay? So when you're checking your x-intercept, your answer has to fall near. The y-intercept is easy because you know you're plugging in